Okay, so I'm reshooting this video because when I first shot the kind of introduction scene where I was explaining how the whole wiring assembly worked, I got my blocking really terribly wrong, and I explained everything like a fraction of an inch outside of the frame, so that was annoying. But anyway, it's only my second video, and I'm just still learning how to put together a good video. Anyway, so this is the wiring and all the various mechanical components that are going to go into the lift. And I finally got them all delivered from Amazon, so I can start assembling them, which I did earlier today. So the bits that go into it are a device called a linear actuator, which is this part here. And what a linear actuator is you have a small motor on this end, and then through a system of gears, it turns what I assume is some kind of threaded rod in this end, and then there's a piston. This is the end of the piston here. And then when you apply current and the motor turns, the piston extends. When it gets to its full extension, there's a limit switch inside of this sleeve here, and it turns the motor off. And then the opposite is true when the device retracts. There's another limit switch on this end, so that when it fully retracts, it turns the motor off. The other thing I got was all linear actuators that I found on Amazon take a DC current, so I had to find a way to convert 110 AC to 12 volt DC. 12 volt, and it's like 4.7 amps is the max amperage draw for this guy. So I picked up a $12 AC/DC converter. It's just like a $12 laptop converter, and it's rated for 12 volts and 6 amps, which is a little bit more than I need. So yeah, for 12 bucks. And then the last sort of device is this thing, and this is called a relay. And this is a cool little device that depending on the way that the switch is inside of the relay, it changes the polarity of the current coming out of the relay. Okay, so the polarity is important because depending on the polarity that you're feeding to the power wires for the relay will determine whether or not the piston is extending or retracting. And so what the polarity means in really basic terms is depending on, let's see, hold on. This is kind of a rat's nest. This will look a lot better once I get it all mounted up into the carriage assembly. What the polarity means is that, so these are the wires coming from the power source right here. Okay. So what polarity means is that depending on if I have the positive going to the positive and the negative going to the negative, or the positive going to the negative and the negative going to the positive, will determine whether or not the piston goes in and out of the linear actuator here. So that's what the relay does for you. Is it basically switches the polarity for a current input. And the way that it does that is with this last little bit here. Let's see if I can clear some of this out of the way. So I'll show you the back of the relay first. So these three pairs of wires that are on the bottom here, that are where the little connector bit is oriented vertically, the way you're looking at it, those are the main current wires. Those are where the 110 voltage is coming through the relay. Okay, and then these bottom two is where a 12 volt DC current goes, and that is what is referred to commonly as the so-called 12 volt trigger that comes out of the projector. So that the effect is that when you turn on the projector, 12 volts is fed through this wire. It's a 3.5 millimeter stereo jack for my projector, and the current is fed through this coil, this white coil here. And the way that a coil functions is that when you wrap a wire around a ferrous core, which is what this assembly is, it turns that, and then you charge the coil. It turns that ferrous core into a magnet, and that magnet then performs the physical operation of closing this switch here. It draws the switch to it, and then that it changes the path of the current, either through these top two wires or these next two sets of bottom wires. And when you connect the main current wires in a particular pattern, that'll switch the polarity. So yeah, so the way that the detail of the way that I have that actually set up is, it was a bit easier to see when I had everything off, but basically it's an X pattern where you have a positive here on the top left, I guess it is to you, and then a positive on the bottom right, and then a negative on the top right, and then negative on the bottom left. So that's the power coming in. And if we run these back to the power source, so this is the power source wire, and we have a positive and a negative here, and then just the positive is the same as the negative, so I'll just follow the positive. If you follow the positive out, it gets spliced into two, and then those two go to the upper left and in the bottom right here, and the same is true for the negative. It gets split into two, and then goes to the bottom left and the upper right. Okay, and then just a quick note about the positive wire coming in. I made sure by using my multimeter that this was the so-called hot wire, and I bought a little 5 amp fuse, and I inserted it into this line to just ensure that I didn't damage any of my other components. This relay is rated for 5 amps, and I was a little bit worried about the linear actuator drawing more than 5 amps, and I didn't want to overload any individual component and risk having it set on fire or any disastrous thing like that. So I bought a package of, these are pretty inexpensive, I don't even remember how much they were, they're like a couple $, for a pack of 2 5 amp fuses. Like if you've ever strung up Christmas lights, if you ever bothered to look in the plug, it's the same style of fuse. In fact, these say that they're for holiday light sets to replace if you should ever blow a fuse. So it's the same thing, and I'll take it out of the pack here. And it's just a glass cylinder with 2 metal contacts on either side, and then there's like a really, literally hair thin wire in between the 2 metal contacts, and the idea is that if you run too much amperage through that wire, it'll heat up, much like a light bulb filament, and just burn up, and then it'll break the circuit. So anyway, so I kind of rigged this up by using these 2 butt splice pieces. Yeah. So me and my engineer friends frequently make fun of a lot of engineering terms because apparently engineers have no sense of humor, and we name things pseudo-sexually without meaning to a lot. And so, butt splice. Here it is. So anyway, you take the way that I work these there we go. The way I work these butt splices in. Yeah, Claire's laughing at me. So the way that I did that, because the outside diameter of the fuse was just a little bit larger than the inside diameter of this splice. Well, first of all, I'll explain exactly what this is. So this is a plastic sleeve with a metal sleeve inside, and the traditional or usual way that you would use this thing to perform a splice is you would insert a wire in this side and a wire in this side, and then you crush the metal sleeve, and it holds the two wires in place and maintains the connection. So what I did instead is I heated up one end with just like a hair dryer to soften up the plastic, and then jammed, being careful not to press too hard, because I imagine if that glass shattered, I would have driven glass shards up into, my fingernail, which would be unpleasant. So I carefully, inserted the glass fuse into the softened plastic edge, and then I flipped it around and took a stripped down wire. I'll point at the thing to illustrate. So after I had it inserted in one of these ends, I then stripped down a wire, inserted it until I felt like I made contact, and then I took my multimeter. This is a multimeter, just in case you don't know. These are worth every penny. I think I got this one for, I don't know, like $20 or $30. And I mean, it does pretty much everything. Anyway, they're incredibly useful. Yeah, everyone should have one. So anyway, so then I used the multimeter just to confirm that I had a good connection between this end of the fuse and this wire, and then I crimped it to maintain the connection, and then I just repeated the same thing. So once that was done, I had this nifty little sort of handmade fuse gizmo. I was a little bit worried because it took me like 15 minutes to construct this little thing. I was a little bit worried that I would instantaneously blow the fuse, and I would have to I mean, that would mean that I had undersized the relay, because that's the bottleneck in the whole circuit. That would mean that I would be delayed by like a few days. I'd have to go online and locate another relay to replace the one that I had just discovered was too small to handle the amperage loading. But as you'll see in the video, I tried loading up the linear actuator as much as I could to draw as much current as I thought was reasonable, and this thing stayed put. So I think we're going to be good for the final design of this thing. Okay, so I think I explained everything. I talked about the relay and kind of how those function. I could probably talk about those more. I thought it was a bit confusing at first when I started messing around with it, but they're really not that bad. There's a ton of YouTube videos out there that talk about relays. Oh, and this is officially called a double pole, double throw relay, and it's got a 12-volt DC coil, and it's rated for 110, 240 volts, and 5 amps for the through current. Sometimes people call it a double pole, double throw, 12-volt coil relay to specify the size of the coil. Yeah, but these are super cheap. These, like this one I got, it was like $5 or something. It was really inexpensive. So those are cool. Oh, I was going to talk more about the trigger plug. So I did a lot of research on this. I went on to a bunch of like AV junky forums and stuff to figure out the correct type of plug. And what a lot of them will say is that using a mono plug is totally fine. And what that means is that instead of there being 3 distinct sectors on the plug, there's only 2. There's only a hot and a ground. Here, because it's stereo, there's a ground, which is this sector furthest up on the plug, and then a left and a right, depending on what it is. So what you'll have to do if you're doing it for your own projector, you'll have to dig out the manual, and hopefully the manual will instruct you as to what the different sectors are charged for. I think I found that most of the time this section closest to the plug is always going to be ground, which sort of makes sense in a way. And then my particular projector, which is an Optima HD141X, yeah. The middle band was the 12 volt trigger, and then the end was, they said it was just reserved, whatever that means. And then I saw a lot of people that the tip was actually hot, and then the middle band was something else. So just check, you know, if all else fails, buy a stereo, you can't go wrong with that, and plug it into your projector, you know, strip your ends, and, you know, use your very useful multimeter to deduce where you're getting your 12 volt current off of, which particular sector you're getting your 12 volt draw off of. Yeah, you can figure out anything pretty much, or I haven't found anything that I can't figure out using a multimeter, just kind of thinking about the circuitry that you're dealing with. Also, I'll say that buying these little crimping things is totally worth it. Typically, I'm just kind of the guy that will, you know, twist the metal ends together and, you know, plaster it with black tape. But these, I mean, for a package of these, it's like $1.50 or something like that for a dozen of them, and that is money well spent because it just looks a lot tidier. And I don't think actually this would have been even possible trying to like solder all these connections on, and I don't know, it just would have looked a lot meaner. That's a Slapshot reference for those of you that like Paul Newman. Anyway, it would have looked really shitty. So anyway, buy these things. Yeah, I think that's it. So the next video, I'll be installing all of this, you know, what looks like a nest of wires into the carriage assembly, and hopefully I'll clean it all up so it doesn't, you know, look so obviously completely homemade. And hopefully the next video we'll see this thing working. Okay.
Thanks for watching.
Oh God.